Hi everyone, in this episode we're going to be starting work on our custom terrain shader. For now just getting it to draw different colors based on the height of the terrain. And over the course of the next few episodes we'll be adding in support for textures and some other fancy stuff. Let's start by creating a new shader. So I'll just right click, create shader, and we'll use the standard surface shader as our starting point. So I'll just call this terrain. And then let's go onto our mesh material that we're using and set the shader for that to our custom terrain shader. Alright, let's then open the terrain shader up. And for those of you that haven't worked with surface shaders before, the main point of interest here is the surf function, which is going to be called for every pixel that our mesh is visible. The main thing that we want to do in this function is set the color of our surface at that point. And we do this using the surface output standard parameter, and in particular by setting its albedo property. So, for example, if I delete all of the stuff in here and simply say output.albedo is equal to float3010, that's referring to red, green, and blue, and then save this, you can see that the entire mesh turns green. Okay, so ultimately what we're going to want to do in this shader is blend between different textures based on the height of the surface. So what would be very helpful to have inside of our surf function is some value between 0 and 1 telling us how high the terrain is at that point. Now, by setting our input struct to have a float3 called worldPos, we can get the world height of the surface at that point, but we're obviously going to need to know what the lowest and highest points of our terrain are in order to get that value between 0 and 1. Let's start just by deleting all of this extraneous stuff. So we don't want any of those properties, and we don't want any of these variables here either. We are, however, going to want a float called min height, and another float called max height. We're now going to need one of our scripts to send the shader the values for these two variables. So the script that has access to that sort of information is our terrain data script. So let's create over here a public float, and let's call this min height. All right, we'll make this an accessor with only a get property. So we'll tell it to return uniform scale multiplied by mesh height multiplier multiplied by the mesh height curve evaluated at 0. All right, and then for the max height, that will be pretty much the same thing. We'll return uniform scale multiplied by the mesh height multiplier, but this time it will of course be the mesh height curve evaluated at 1. Alright, so we now have a way of getting the minimum and maximum height of our terrain, but it shouldn't be the terrain data that is sending information to the shader, because we have our texture data script to do that. So let's create a new public method. I'm going to call this update mesh heights, and this is also going to take in material as well as a float for the min height and a float for the max height. It will then say material.setFloat, so we're going to send that value to the shader. Remember, in the shader we called it min height as well. Make sure you write it exactly the same as you wrote in the shader, otherwise obviously it's not going to work. And then we pass in the min height, and do the same thing here, material.setFloat max height, and pass in the max height value. Alright, while we're here, let's just add the create asset menu attribute. Alright. Now we're going to go into the map generator, and when we generate a new map data, just at the end here we can say texture data dot update mesh heights. Let's pass in our terrain material, as well as terrain data dot min height and terrain data dot max height. Now, it's worth noting that these values aren't actually going to be correct if we have applied a fall-off map, because then what used to be the highest point in the terrain might have been flattened down to a fairly low point. So we're going to have to account for that later on. For now, we're just going to not worry about it. So let's save this. And in our terrain assets, let's create a texture data asset. Just call this default texture. And if we go into the map generator, let's add the default texture asset into the texture data slot. And let's also add our mesh material in there. Alright, so now going back into our shader, let's use the information we now have to set our terrain to be white at the highest points and fading to black at the lowest points. So using our world position Y value, we want to get 0 if it's equal to the min height and 1 if it's equal to the max height. So let's create a little function here that returns a float, and we can call this inverse lerp. So we'll take in A for the minimum value, B for the maximum value, and then just a float value for the current value. Alright. We'll then simply return the difference between value and the minimum value divided by the difference between the maximum value and the minimum value. This is assuming, however, that value is actually in the range of A and B, so it's not less than A or greater than B, but we don't necessarily want to assume that, so we're actually going to saturate this result, which just means to clamp it in the range 0, 1. So now, in our surf function, let's say float height percent is equal to inverse lerp, and we're passing in min height, max height, and then input dot worldpos dot y. Let's then set our color to be simply height percent. One note if you're not used to working in this language, which by the way is CG, a variant of high-level shader language, the function has to be declared before you call it. So if I were to put this function down here, we'd get an error because it hasn't been declared yet. So I'm going to put this back over here, save this, and go into Unity. And now we're going to want to generate the map. And so now that we've sent the minimum and maximum mesh height values to the shader, it's drawing a nice gradient from black to white. Of course, since we are using a fall-off map here, as I talked about, we're not getting the full range of values. So until we sort that out, let's go into our terrain assets and just turn off the fall-off map. And for the same reason, just make sure that your noise normalize mode is set to local for the time being. Before we continue our work on the shader, I want to address something that's a little bit annoying. So if we go into our texture data script, let's just do a little printout when the mesh heights are updated. So you can say debug.log heights updated. And we should see if we save this and go into Unity, then when this recompiles, it will get a heights updated call. However, the mesh is turned completely white, indicating that those values have not been set in our shader. And the reason for this, I believe, is that when the scripts recompile and we get our onValidate callback, which ultimately leads to the heights being updated, it then sets the heights, but the shader recompiles after that, and so the heights get cleared. As a workaround for this, let's head over to our updatable data script, and instead of notify of updated values being called immediately when onValidate is called, we're instead going to make use of the editor application update callback. So we'll say Unity editor dot editor application dot update, and we'll subscribe our notify of updated values method to that. And then because we don't want this to be called every frame thereafter, we will immediately then unsubscribe it from that callback once the method is actually called. So this will just delay the calling of this method until the shader is actually finished compiling. So if we go back here, you can see we now get this callback and the values have been set in the shader. Now the one thing this doesn't address is if we actually make a change to the shader itself. Say I just add a comment here and save. You can see we don't get any callback for this, and the shader loses its data. So because I'm not aware of any callback for when a shader finishes compiling, the only thing I can think of to make this slightly less painful is to make it that if we manually update our texture asset, it then reloads the previous min height and max height values. So to make that happen, let us create a float up here called saved min height, as well as saved max height. And let's remove this debug.log here. And before we update, we can just say saved max height is equal to max height, and similarly saved min height is equal to the min height that we receive. Then when apply to material is called, we can update the mesh heights, passing in our material, as well as the previously saved min height and max height values. Alright, so if we just wait for the scripts to recompile, we should get our callback as normal, and this should work fine. But if we go into our terrain shader, let's make a change. I'll just delete the comments and save. You can see this clears here. But now if we manually update our texture asset, that reloads after a moment. Alright, so with all of that out of the way, we can start making some more rapid progress on our shader. So as I mentioned, we're going to ultimately be blending between different textures, but for now let's just get it working with colors, since that's going to be a little bit easier. So opening up our texture data script, let's create a public color array, which I'm going to call the base colors, as well as a public float array, which I'll call the base start heights. So each of these floats will just determine the starting height for each color, and they'll all be in the range 0 to 1, so we can just add a range attribute here, 0, 1. Okay, and then when we apply to material, we want to say material.set color array. Let's call this the base colors, and pass in our base color array. And we'll also want to say material.set float array. Call this the base start heights, and pass in, of course, base start heights. Now we'll also be passing in a third thing, material.setInt. This will be called the base color count, and I'll explain why we need this in a moment. But this will just be basecolors.length. Alright, so going into the shader, we can make some more variables here. Int base color count, then a float3 for our base colors. This is an array, but unlike in C#, the square brackets come after the variable name, not after the type. Alright, and then float base start heights. As always, remember of course that these need to be spelt exactly the same as we spelt them over here. We won't get any sort of error, things just won't work, so it's a very easy way to go wrong. Now what we do need to do is initialize these arrays with a certain size. So we're going to create a constant static int called the max color count. Let's set this equal to, say, 8 is the maximum amount of colors we can have, and we'll pass that in there. And now maybe you can see the reason for having the base color count, because the size of these arrays is always going to be max color count, but we're not necessarily going to have that many things in them, hence why we need to know exactly how many things we have in them. So what we'll now do in our surf function is loop through all of our base colors, so for, and the syntax here is exactly the same as C#, int I equals 0, I less than base color count, I++. We'll now want to set the current color, but only if the height percent is above the corresponding base start height. So let's create a variable called drawStrength, and we want this to be 0 if the height percent is below the base start height, and 1 if it is above the base start height. So we can set this equal to sine of height percent minus the current base start height, so base start heights I. So currently this will be -1 if the height percent is below the base start height and 1 otherwise. So we want to clamp that -1 to instead be 0, and we saw how to do this before using the saturate function. Alright, so now we can simply say output.albedo is equal to base colors I multiplied by the draw strength. But hold on, there's a problem. If the draw strength is 0, then we will be overwriting the output albedo with plain black. But we don't want this. If the draw strength is 0, we should instead retain whatever albedo was set to previously, and we can do this by saying output.albedo is equal to the current albedo value multiplied by 1 minus the draw strength plus the rest of this. So if draw strength is 0, then this whole term here will be 0, and this will evaluate to 1, so we'll be setting the albedo just equal to itself. In other words, we retain what we had previously. That is great, so let's save and go into Unity. And all sorts of errors. This is just because our arrays are currently empty. So let's open these up. Let's just start off with a size of 2 for both of these. And I'll make this, say, red and then blue. And let's just turn on auto update. And it turns out that that isn't actually what it was complaining about. So let's go in here. I think I spelled something wrong. Yes, I didn't add a G in there, which is very bad. So just save that. Let's go back here and update this. And there we go. So our second slider is currently at 0.5, which determines the starting height for the blue color. You can see if we move this down, then that starts lower down. And if we increase the value, of course, the blue starts higher up. And the same thing for the red. If we make this start above 0, then it will move up, and just a plain black will take its place. Okay, so what if we want to add in a third color? Let's increase the base colors to 3, and we'll also increase the base start heights to 3. But now the shader here is complaining because our arrays have been resized. So the way to get around this is just to save the Unity project and then update, and it should be happy now. So let's make this color, say, yellow, and move this over here. Alright, we've now got 3 colors. Just a quick something I forgot about. You'll notice that if I save this, then this of course all loses its data, and if I press update, nothing happens, but if I change the values of one of the sliders, then all our data comes back, which is a bit strange. The way to fix this is to go to our updatable data editor script, and when we update, we're going to say editor utility.setDirty target, which will just notify it that something has changed, so it knows to update it. So now, if we save and go onto our texture data and update. You can see that works fine now. Alright, so that is everything for this episode. In the next one, we will just continue working on the shader. So until then, cheers.